Okay, welcome back. My name is Nyobuchi Ase, and so I'll be doing network traffic analysis, spotting SSL stripping in actions. Is SSL stripping. It's basically a man-in-the-middle technique in which an attacker intercepts and modifies traffic to remove or prevent TLS encryption between the client and the server. So this basically causes the client to communicate over HTTP instead of HTTPS. So the attacker retains the secure HTTPS sections with the server while relying plain HTTP to the victim, so enabling eavesdropping and credential capture. So basically turn HTTPS, which is the secure version, to HTTP insecure. So how does this work? So the victim initiates an HTTPS request to the website. So the attacker intercept the request using app spoofing or rook access point. So if you've not watched the analysis I did for the app spoofing, I encourage you to watch part 1 and part 2 and part 3 and part 4. So part 4 is the DNS spoofing. So I encourage you to watch that to be able to follow along. So another aspect of it, the attacker connects to the website over HTTPS but relays the response to the victim through HTTP. So HTTPS uses the common port for HTTPS is 443. Then insecure version, which is HTTP port, the common port is port 80 or port 8080. So the victim annually interacts over HTTP, exposing sensitive data in plain text. So what are the indicators of SSL stripping? So initial request versus response. So the user's initial request may be for HTTP using port 443, but the subsequent packets immediately shipped to encrypted. So why is it called insecure? Because it's encrypted. And you see like indirect link rewriting, monitoring. So monitoring for indirect status code of 301 or 302 that persistently direct an HTTP request to HTTP source resources. So other indications of SSL stripping is certificate errors. So although the attacker usually tries to hide this, the initial HTTPS, TLS and SSL. So handshake may fail or display self-signed certificate if the attacker uses a more direct proxy technique. Alright, so let's get started. So let's say we want to examine so the handshake. So working with the previous Wireshark, as you can see on the screen here on part 5. So I'm just gonna copy this. Clear this first. So type this command TLS. TLS dot handshake. tls.handshake.type, and then tls.handshake extension, extension server name, custody domain. So I'm just gonna look for copy the domain name, so I don't want to type the whole thing. Okay, so that's it about 31 display packet. 31 packet. So beautiful thing about Wireshark, if you check this RO, you see your previous filter that you apply, you can sort of reuse them. So let's say I want to reuse one of those filters that we used before, which is DNS response. So we want to reuse this one. So this time, instead of Google, we type the, so if we're following along on the previous analysis, so we're going to use the IP address the attackers forged the DNS response return with. So it is 192.168.10.55. Try that. Back to. About two of those. So that's sort of isolate the DNS response from the attacker to show the victim was pointed to the attacker's IP. So this is the victim, which is the destinations, and this is the attacker's IP. .10.55, and the victim in this case is the 10.10. So let's apply another filter. Let's say this time so let's apply We filter on the server IP and the attacker's IP. So like that filter HTTP and the attacker's IP dot 168. Okay, let's do this with the source IP, whichever order. Let's say attacker's IP .55. Okay, let's make this the source IP and the destination IP. 192.168.10.55. It's about the same. So what if I make this? Would I get the same result? 55, then this 10. Change the order. The attacker's IP and would I get the same result? Yeah, nothing. So switch the order, no result displayed. So in summary, so app spoofing, another word for spoofing is catch poisoning. So the app spoofing, the attacker sends unsolicited app is out claiming they get to his IP. Then DNS spoofing, which is a forged DNS response or the victim DNS query. So forged DNS response from the attacker. So not SSL stripping, which is TLS downgrade or credential capture. So another word for SSL stripping is credential capture. So the victim initiates a connections to resolve IP, then HTTP to the attackers. So the credential post request observed. Alright, that's it for this part.